I just said, okay, find all zeros. Okay, so real quick, just to, because I know we have a quiz tomorrow and I want to relate these things back. Let's go back to 15. I'm not going to write anything else, but can you tell me what the description would be for this root right here? One single real root, right? Okay. And what would the description be for these? Nope, not complex. What does complex have to be? I. These are just roots. So these are two single real roots. So the final answer for this description wise would be three single real roots. Okay, here's my question. If it's three single real roots, how many times would it cross the x-axis on a graph? Three. Okay, now let's do this guy. So in this one, we're gonna do the same thing, equal it to 0. This one's slightly unfortunate. I can tell that I have to do quad formula because they didn't factor this for me, and it's a trinomial. You could try box and diamond, pretty sure it doesn't work. But this guy right here is 0 already. And then that guy is going to be quad formula. X equals negative b plus or minus square root b squared minus 4 a c all over 2a. Twelve squared is 144. 4 times 8 is 32. Okay, let's go over here and see if we can break down 112. 112 is 2 times something. 56. What times what is 56? 28 and 2? Which is 4 times 7, which is 2 times 2. Okay, what do I do with this factor tree here? In a minute. Anybody? Factor tree? No? What are you looking for? Hopefully matching pairs. Now, for me, I'm going to circle this 2 and cancel this one. I'm going to circle this 2 and cancel this one. My 2 circled 2's multiply together on the front of the root, and then 7 is the only thing left over. Okay, so I have x equals 12 plus or minus 4 root 7 over 2. And then I can reduce. So this becomes a 6. This becomes a 2. This becomes a 1. Equals 6 plus or minus 2 root 7. Okay. Here's the big question. Are those two real? First of all, do you recognize that there's two of them? Even though I wrote one with a plus and one with a minus, do you know that those are two separate things? Okay. Are they real or complex? Real. I want you guys to really know that complex does not mean complicated. They look complicated. That doesn't mean that they're complex. They have to have an I to be complex. Okay, so if I scroll back up and I point to this and I point to these, if I asked you to sketch this without a graphing calculator, how many times would you cross the x-axis? 3. 1, 2, 3. And where you would cross the x-axis, you'd know 0, and these two you'd probably be hazy on. I would do a little bit in front of 6 and a little bit behind 6, personally, but you wouldn't really know. That's okay. But there should be 3. Okay. All right, number 17. Number 17 is quite a bit easier than number 16, which is great news. Okay, factor each and find all zeros. Mrs. Talbot, you said that we can't factor a cubic. What do we do? Well, this is what we're learning this week. So this is a warm-up that actually has to do with our current lesson. And what I'm going to do is the polynomial division box we learned yesterday. But in order to do that, I need to figure out what to divide by, and I'm going to use a graph to do that. So I'm going to look at the graph. Can you guys tell me one of my roots on this one? -1. Can you guys see that there's a double root at -1? Okay, and I don't know where the other one is. It's zoomed out. Probably I'd have to find it. Doesn't matter. I just need 1 to get started. So I'm going to put x equals -1, and I'm going to make myself a note that I got that from the graphing calculator. So just when you're looking back at this, you'd be like, where did she get that -1 from? Just want you to know I had to actually figure that out. Okay, so what size box? Thinking about yesterday? You're like, I'm not sure yet because I probably thinking that it's 3 by something. Okay, what I want you to do is think about how do I change this root into a factor? So we're going backwards now from root to factor. So this would be x plus 1 as a factor. Does that make sense to everybody? So x plus 1 is going to be my factor on this side. X cubed minus 9x squared minus 21x minus 11. So this is where I really want to draw you in to notice that when I said factor, I really mean divide. Okay, practicing from yesterday, x cubed in the first box. X times what is x cubed? X squared, which means this box has to be x squared also. Okay, now this is the skill that we're working on right here. This is our current skill right now. I have 1 x squared tile and I need -9 x squared tiles. What do I have to put here? -10 x squared. How's that skill coming? And if you were not here yesterday, then it probably is not there yet, but that's okay. Okay, so that means the top has to be -10x. And that means this also has to be -10x. Okay, I have -10x tiles. I need -21x tiles. So this needs to be -11x. Does that make sense? And then that's my moment where I have my little like, you know that emoji where it's like the little cone and like the little party stuff's coming out of it? Yeah. I just every time that it comes out evenly in my box, I'm like, like the little party emoji. Super satisfying. Okay, so I said to factor. I'm not all the way factored yet. I have, oops, it's f of x. Hold on. I almost wrote y there. Okay, so f of x equals, so I'm saying that this factors into this times this. So x plus 1 times x squared minus 10x minus 11. So this factored into this times this. Okay, and now I'm going to diamond and box this part, hopefully. Please, please let it be box and diamondable. I do not want to do quad formula again. Negative 11 and positive 1. Right? 9:47 a.m. Checking in. Okay. Now this bit is saying, here's my factor from my original box, my division up here. So that's that. And then this guy factored into this times this. Okay, I'm going to rewrite it to look nicer. Okay, what's the root here? X equals negative 1. And what kind of a root is that? Double. And x equals positive 11. Now, how do I know that I'm done? How do I know I found them all? Yeah, it's degree 3. So I need to make sure that I have 3 answers. And the double counts as 2. So you guys see where this is going. So you're going to use that polynomial division box to get it down to a quadratic so that you can do your diamond box. Okay. Scooch this to the side. We're going to do the notes first, and then I'll take all your questions. The notes are not long, don't worry. Just scooch your packet aside for now. All right, you guys. So sitting down, pretending you're taking the quiz. This is one of the problems. First thing you want to think to yourself is, what size box should I make? And remember, it only works most of the time, not all the time. Don't freak out if your box isn't perfect, but it's a good place to start. What size box should I start with? 4 by 2. Okay, so you look at the degree of this, and then you see how tall it should be because there's two things here. So 4 by 2. Okay, so make yourself a 4 by 2 box. Went all crazy there. I didn't use a ruler. Okay, now, do you remember yesterday how I said that I'm like really, I'm a linear thinker and I'm a Virgo and I like all my things to line up underneath because it's pretty? Okay, there's actually a reason for that too. Do you guys see how there's 5 vertical lines in this box? 1, 2, 3, 4, 5. But my dividend only has 4 terms in it. Can you tell which term is missing? The squared one. So 4, 3, uh-oh. Okay, the reason I like to line them up is because this works best if you put a placeholder in the spot where it's missing. So x to the 4th minus 6x cubed plus 0x squared plus 18x minus 4. So now you kind of have to keep your eyes peeled for any missing terms. Okay, x to the 4th in the first box. What does the top have to be? This is an easy one. X cubed. This has to be negative 2x cubed. Okay. I have negative 2x cubed, and I need negative 6x cubed. So this needs to be negative 4x cubed. Okay, now this is the reason I like to put the 0 placeholder in. It helps me figure out what should be here. I have 8x squared. I need 0x squared, so this needs to be negative 8x squared. Okay, I have 16x. I need 18x. Yay. Ta-da! Okay, so the answer for this problem is x cubed minus 4x squared minus 8x plus 2. Okay, now in the notes and the warm-ups we did, I kept going, right? I did box 9 and stuff. I really want you guys to understand the difference in the directions here. This problem is a division problem. It says divide. Divide, I divided, I did, I found an answer, done. I didn't say factor, I said divide. So dividing just do the box, write down what's on the top, you're done. We like dividing problems because it's one step, it's over. But when it says factor, you gotta keep going. So anyway, this one's done. Do you have any questions about example one? Any of the things I did? How are you doing on that skill of figuring out what needs to go here? How are we doing? Good? Okay. All right, let's go to example two. Which, by the way, is going to be number 90. I just lumped them both into notes. Okay, now I wrote this problem down differently, but it's the same exact style of problem. So this one had a division symbol in it. This one has a fraction bar that means divided by the same thing. What size box do I need in this one? Yep, 3 by 2. Great job. Degree 3, 2 terms. Okay. 6x cubed plus 11x squared minus 12x minus 1. No missing terms on that one. Don't have to worry about any zero anything. 3x plus 1. Okay. First box, 6x cubed. So the top has to be 2x squared. 2x squared times 1 is 2x squared. Two x squared plus what is 11x squared? Nice. Okay. This is a little bit advanced. I have positive 3x. I need negative 12. Negative 15. Nice. Great job. Oh, no. I didn't get the party emoji. Dang it. Okay, so what do? I make another loop. Just keep my process going. I have negative 5. I need negative 1. What has to go here? 4. Okay, so my answer is 2x squared plus 3x minus 5 plus remainder over the divisor. Okay, before we move on, how do you feel about polynomial division with or without a remainder? Doing okay? Okay, so now we're going to do like our last problem of today is kind of like a discovery type problem. So go ahead and set this up. Okay. I'm gonna give you guys a different division problem to do for every table. And really, I don't know if you wanna, I'll do the same one as you and we can check each other. So I'm gonna bring you a post-it note and I need you guys to be like, when you're ready, I'm going to assign each table a different division column to do. I'll be very clear, don't worry. Okay, this table right here. I want you guys to put x plus 3 on yours. X plus 3, this table. We're gonna do x plus 2. And we're gonna put x plus 2. You guys are gonna do x plus 1 on your side. Okay. I'm gonna do 0 myself because it's weird. Okay, you guys on your side are gonna do x minus 1. You guys are gonna do x minus 2. You guys are gonna do x minus 3. You guys are gonna do x minus 4. Okay, I want you to all work on it. And what I want you to do is write your remainder. Listen very carefully. Do your problem, write your remainder on this post-it note. Okay, see if you guys can agree on your remainder. And if you can agree on your remainder, bring it on over. Have somebody bring your post-it note over here. Perfect. Correct answer. Mm-hmm. Yep. 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 Zero. Missing one. Is it? Hold on. Okay. All right. I want to show you something interesting. I typed this equation into the graphing calculator and I went to the table. There's 2 times. You had x plus 1, so it's negative 4 on the table. Because you just that. Okay. So, you guys see why this is interesting? Where did I get these numbers from? They're posted. What are these? Remainders, but they're also coordinates on the graph. You can actually do polynomial division instead of plugging a number in. You know how like you do like a function machine, you plug in 1. So if I did like 1 cubed minus 2 times 1 squared minus 3 times 1 plus 10, I would get 6. But I can also do polynomial division, switch the sign, and my remainder will be the number that I get out at the end. It's crazy. Polynomial division is the same thing as a function machine. Okay, that's called the remainder theorem. So remainder theorem says remembering the switch sign, of course. So the remainder is equal to the value of y when you plug in for x. If you love polynomial division, you could do this instead of plugging in. I don't know about that. Okay, now there's a special one, a special piece of the remainder theorem called the factor theorem, which talks about this guy. What was the remainder there? There wasn't one, right? 0. What does that mean? That I put my little check mark and I have my party emoji, right? Okay, so I got my party emoji at -2. Okay, so earlier on the warm-ups, did it come out evenly? Yes. And why? It's an intercept. It's a factor, it's a root, it's a zero. So you can find roots when the remainder is zero. This says value, by the way. If the remainder is zero, that value is a root. And that's the whole point. That's what we want to find for our sketching and stuff. So we would know where to put that dot on the x-axis. Back in the day, when I was in high school, we did this in a very different way. So they wouldn't let us use a graphing calculator, but they also wouldn't give us any roots. And we had to just guess and check. So like you guys were making your table, I would have to make a table and I would have to guess and check and like try this one to try to get a zero remainder. Try this one to try to get zero remainder. Except if you're smart, take a look at the constant in the original problem. It's 10. For this box to be 10, a matching box, what are the only numbers those could possibly be? 5 and 2 or 10 and 1. So don't try all the other stuff. Just start with 1 and then try -1 and then try 2 and then try -2 and then try 5 and then try -5, which is still terrible, but at least you could narrow it down from infinity, right? Am I going to do that to you? Absolutely not. But back in the day, that's what we had to do. Because our teachers were mean. No, I'm kidding. Just, I don't know. Did I tell you guys also they didn't ever teach us box and diamond? I didn't know box and diamond until I was a teacher. So like if I was factoring, you just had to guess and check. Like you just say x squared plus 6x plus 8 or whatever, and you'd be like, okay, x squared makes x and x, those go in the front. And then 8 has to be 4 and 2 or 2 and 4 or 8 and 1 or 1 and 8, and you'd like mess with the numbers until you got it to add to 6x. And there was no technique, there was no diamond. It's just guessing away. Same with this. But anyway, okay. Now, can you guys find all of those worksheets in your packet that you might have questions about? Use me. And then I'm going to give you a hint for quiz practicing. Just a quick note, tonight's homework is 4 CPMs, but what can I do for you from either the factors to standard form worksheet or the chapter 8 quiz 2 review? What can I answer for you? Yes. Okay. Number 10 is great. Excellent question. I'm going to try to figure out where I think your question is in my mind, like Zoltar. Okay. Write the equation in standard form. Oh, great. Of the 4th degree polynomial. This is a very big hint. 4th degree polynomial that has a double root at -2 and a single root at 3 plus 2i, and it passes through the point -140. Okay, so y equals a, double root at x equals -2, so that's x plus 2 squared. And a single root at this, so that's x minus 3 minus 2i. Okay, real quick. Does that make sense so far? So I did the x in the front and then switch the sign, switch the front. Okay, however, there's 2 things here that should be hinting to you that this is not it. Not all the way done. First, I circled the word fourth. I only have 3 degrees going on there right now. Also, I told you guys that if you have an imaginary or an irrational, it needs its conjugate. It has to have its best friend. It's very upset and lonely. Okay, what would its best friend be? 3 minus 2i. Okay, so I need another guy that's x minus 3 plus 2i. Okay. And are you comfortable with the x minus 3 plus 2i switching signs? Okay, now my advice is always to multiply out the i's or the roots immediately because you're never going to see an equation that looks like this. This requires a 3 by 3 box, but remember, you don't have to do the whole thing. When you do a 3 by 3 box with conjugates, you can skip all 4 of those and you don't need to find them. Just put lines through them. X squared negative 3x negative 3x 9. Okay, this is negative 4i squared, which is 4. Is that okay so far? Okay, so now I have y equals a x plus 2 squared x squared minus 6x plus 13. Okay, are you completely clear from where that all came from? Okay, now this is the point where I would solve for a. So I plug in my x and y. Okay, this might be the hardest part is this little order of operations. Okay, so negative 1 plus 2 is 1. 1 squared is 1. Okay, let's go slow. Negative 1 squared is 1. 1 plus 6 plus 13 is 12. What a relief. Mr. Talbot, pretty sure you didn't give me enough room in this problem. Yeah, you're probably right. Okay, now I'm going to rob some space from next door because it said standard form, so I need to multiply out all the boxes still. I'm going to focus on this bit right here, x plus 2 squared, which I could have done earlier, by the way, just like off to the side, but I didn't, but I could have. Oh no, terrible news. Do you see the terrible news? Yeah. Now, I need to tell you guys something because this is one of those cases where we're over preparing you for a quiz. I don't know if you guys noticed, but it said given a graph. I can't give you roots or eyes on a graph. They're going to be whole numbers. I'm completely over, like when you're on the cross country team and your race is 3 miles, but they make you run 10, so the 3 seems easy. That's this whole thing right there. I don't even know if I have enough room. Holy tamales. Okay. Did I forget a cube here? Yeah. 28? Is it 28? Does anyone know if it's 28? 52 minus 24? Nobody? Nobody in the whole room? Like if the only way we could escape this room is to know what 52 minus 24 was? 28? I'm so scared to see if I got that right. Mathematical overkill for your quiz. Overkill. Because remember, I'm giving it to you from a graph. So there's not going to be the I, isn't it? Okay, now I'll take questions still, but I want to give you my little hint to practice for the quiz. So find me the answer sheet. This is really strange, but I also don't want to look. Did anybody check? Did I get it right? I did. Oh, thank you. Okay, this is how I would practice for the quiz if I were you, just from Mrs. Talbot's hint. Okay, what I would do would be I would take something and cover up the actual roots in these problems 3 through 6. I mean, after I checked my answers, of course. Okay, so the problem is going to say, sketch me a graph that's degree 3 with this end behavior and these kind of roots. That's what the actual quiz looks like. Okay, so I have this one. Okay, it says, okay, so sketch me something with degree 3. That means it has to have 3 directions, right? Okay, with that end behavior. So do you guys understand that the top line is the left arrow? So that means it's starting down with 1 real root and 2 single complex roots. Okay, so this is what my little miniature brain would do. I would go, okay, Miss Talbot, I got you. Fine. Degree 3, 3 directions. It needs to start down. So I would be like, all right, needs to start down, end up. It needs 1 single real root. So it's going to cross the x-axis 1 time, 2 single complex roots. So that means it's not going to cross again because complex don't actually hit the x-axis. But this gives me my 3 directions. Okay, is this the only option? No, because you might have wanted to get you're scared about the complex. You want to get it out of the way. You could have done it underneath the x-axis. You could shift this any which way. But as a grader, I have to make sure that I have represented all possible scenarios. Do you guys understand what it's going to say? Okay, so let's practice this one. Do you guys want to keep going? Do you want to do another one? Or no? You got it? One more? Okay, let's do number 4. Degree 4. It says starts down, ends down, 1 double and 2 singles. Okay. Degree 4 starts down, ends down. Don't look at the picture because there's like lots of options. 1 double, so that means it's going to bounce off. And then 2 singles, goes through, ends down. Do those bumps need to look like that? No. Does it need to be that tall? No. Does it have to have the double first? No. You guys get what I'm saying? You could sketch any picture that you want, just as long as it matches the requirement. But remember, when it's complex, that means it doesn't go back across the x-axis again. So you got to do your directions above or below. Does that make more sense for what the bullet point was saying? Like, given a description, make me a sketch. That's what that was saying. Okay, I have 4 minutes. Anyone want to ask anything quick? And polynomial division is just polynomial division. Like, this is easy. Oh, by the way, we're practicing polynomial division again tomorrow before the quiz, so. All right, you guys, come ask me anything individually if you want. I'll hang out a little bit. Otherwise, thank you very much.